The moon has been Earth's companion for over 4 billion years. It controls our tides, stabilizes our climate, and lights up our nights. But what would happen if it disappeared right now? The first thing humans would notice is the sky. The moon reflects sunlight back to Earth, providing natural illumination at night. Without it, nights would become significantly darker. Only starlight and artificial lights would remain. Navigation and nighttime activities that rely on moonlight would become more difficult. Within hours, the ocean tides would change dramatically. The moon's gravitational pull causes the rise and fall of ocean water twice each day. Without this force, tides would still exist because of the sun's gravity, but they would be only about 1/3 as strong. Coastal ecosystems that depend on tidal rhythms would face immediate disruption. Marine life would be among the first to suffer. Many species use the moon to time reproduction, feeding, and migration. Sea turtles rely on the full moon to navigate to nesting beaches. Corals release eggs and sperm based on lunar cycles. Fish, crabs, and plankton all follow the moon's phases. These patterns would collapse. On land, animals that hunt or travel at night would struggle. Predators like lions and owls use moonlight to see their prey. Nocturnal insects, including moths and beetles, navigate using the moon's position. Migratory birds rely on it to orient themselves during long flights. Entire food chains would destabilize. The moon also stabilizes Earth's axial tilt. Right now, Earth tilts at about 23.5 degrees. This tilt is responsible for our seasons. The moon's gravity keeps this angle steady over long periods. Without it, Earth's tilt would begin to shift unpredictably. Over thousands of years, the tilt could vary between 0 and 85 degrees. A tilt close to 0 would eliminate seasons entirely. The equator would remain hot year-round, while the poles stayed frozen. A tilt near 85 degrees would cause extreme seasonal shifts. Entire hemispheres would experience months of continuous daylight, followed by months of total darkness. These changes would devastate agriculture. Crops depend on predictable seasonal patterns. Temperature swings would become erratic and severe. Growing seasons would shorten or disappear in many regions. Food production would collapse in areas that currently support billions of people. The length of Earth's day would also change. The moon's gravity creates friction between ocean water and the ocean floor. This friction slows Earth's rotation very gradually. Without the moon, this braking effect would stop. Earth's rotation would no longer slow down at the current rate. Currently, Earth's day lengthens by about 1.7 milliseconds per century because of the moon. Without this effect, days would remain closer to their current length for a much longer time. However, Earth would still lose rotational energy through other processes. Days would eventually lengthen, but much more slowly. A faster rotation has consequences. Stronger winds would develop because of increased atmospheric circulation. Weather patterns would become more violent and harder to predict. Hurricanes and storms could grow stronger and more frequent. The moon's disappearance would also affect Earth's magnetic field indirectly. The molten iron in Earth's core generates this field through a process called the geodynamo. The moon's gravity may play a small role in stirring the outer core. Without it, the magnetic field could weaken over millions of years. This field protects Earth from harmful solar radiation. A weaker field would expose the surface to more cosmic rays and solar particles. Human culture and psychology would also shift. The moon has shaped mythology, religion, and art for thousands of years. Calendars are based on lunar cycles. Timekeeping systems would need to be redesigned. The loss of the moon would be a profound psychological event for humanity. Space exploration would become more difficult. The moon has served as a testing ground for technology and missions. It contains resources like water, ice, and helium-3. Plans to establish lunar bases and use the moon as a stepping stone to Mars would end. Humanity would lose a nearby destination for scientific research. Satellites in Earth's orbit would also be affected. The moon's gravity helps stabilize the orbits of some satellites. Without it, orbital calculations would need adjustment. Space debris could become harder to predict and avoid. Earth's climate would eventually shift in unpredictable ways. The wobble in Earth's axis would lead to ice ages and warming periods that no longer follow regular cycles. Glaciers could advance and retreat chaotically. Sea levels would fluctuate in ways that are impossible to forecast. Coastal cities would face new risks. Life on Earth would not end immediately. Humans are adaptable and could survive the initial changes. But over thousands and millions of years, the planet would become less stable. Evolutionary pressures would force species to adapt or go extinct. Biodiversity would decline as ecosystems collapsed. The Moon formed about 4.5 billion years ago when a Mars-sized object collided with early Earth. Debris from this impact coalesced into the Moon. Since then, it has been slowly drifting away from Earth at a rate of about 3.8 centimeters per year. In the distant future, the Moon will be too far away to have the stabilizing effect it has today. But that process will take billions of years. A sudden disappearance is not physically possible under known laws of physics. The Moon cannot simply vanish. It would require an unknown force or event far beyond current science. However, imagining this scenario reveals how deeply connected Earth and the Moon truly are. The Moon is not just a light in the sky. It is a stabilizer, a timekeeper, and a partner in Earth's long history. Without it, the planet would become a place of extremes. Nights would darken, tides would weaken, and the climate would spiral into chaos. Life would survive, but the world would never be the same.